Wi-Fi driver on XP is, for instance, about 20 interfaces. However, on Vista, we have a lot more. We have about 150 or a little more than 150 interfaces with the underlying miniport driver. So as a result, we have very tight control of the behavior of the driver, and there is a lot of room to experiment and write a lot of interesting tools. So for instance, I'm just going to bring up this file here. I obviously can't go into the details of this, but this is just the driver interface header file. And I'm just going to quickly move over the file just to give you the idea of how many interfaces we have. There are about 150 interfaces. All of this is documented in WDK. And you can also download WDK and look at this header file to get an idea of how you can interact with the driver. So there are about 150 OIDs here. So anyway, these were some of the enhancements and some of the possibilities in which you can extend the Wi-Fi at driver layer and build interesting tools out of it. Noel is going to talk next about some of the enhancements we have done at the service layer and some extensibility that we have tried to provide there.
Okay, so just try and switch back. This is actually an engineering sample of a laptop, so I hope the video comes back without blue screening. Ooh, I'm shocked. So, as Drew just showed, there's a lot more exposure at the driver layer in Windows than ever before. A lot more stuff you can mess with. But we've also expanded on the next layer up at the services layer. So if you look at what we've got in Vista, it's very similar to XP in that there's still a core service. It's now called the wireless order config service. It's doing the same kind of management, managing preferred lists, the order connection logic. It also has the 1x supplicant still in it. We have kind of expanded stuff in terms of how it manages and profiles. Profiles are much easier to use. We now have an integration with the Windows logon process. That actually changed a lot in Vista. We got rid of the old Gina model, which used to bring a lot of third-party code and load it into some pretty important system components. We've now got a new architecture that does credential providers. Well, basically, we plug into that so that we can get, if you do a login to a Vista machine, we can get those credentials that you're providing to Windows, and we can provide them to 802.1x at the same time. So we can actually do a synchronized login to the network. This addresses a bunch of different customer scenarios where they want a tight network control. Another interesting area we've got is we've got extensions into diagnostics. So Vista has a rich diagnostics framework. For example, if I go home and my wife had changed the WPA2 key on my network at home, if I just connected blindly, I brought up our IE, I'd get a 404 when I try to go to a page. I can hit diagnose in IE, and then we'll actually go and ask every layer in the stack below it if there's any kind of problems. And it'll derive this fault tree of all the potential problems and try and ask each component in turn if you've got an issue. So finally, it'll get down to the wireless layer at layer 2. It'll say, well, it looks like there's a mismatch key problem. It'll provide back a set of possible resolutions, and those will be presented back to the user. In this case, they'll actually be taken to the UI where they can go and change the key. The other area we've done a lot of work is kind of in extensibility. So there's IHV extensibility where you can add a code that can modify the either security or the connection process, and then some more abilities to add new EAT methods into the system. So if you saw John's talk earlier, he talked a bit about things like service hardening and some of the changes we've done in process. So again, our services had to go through that, and we made a few changes. In XP, wireless zero config is an always-on service. It's running on every single box. And one of the core reasons for that is it manages wired 1x as well as wireless 1x. There's no discovery mechanism for wired, so it's there all the time. In Vista, we made some changes. First off, we separated the two services apart, so there's now a separate service of managing 802.1x on wired networks, so you've got more control over what's running. It's optional on server SKU, because there's not that many people that really want wireless on server. And also, we've got an NDIS co-installer, so you don't actually start running the wireless service until you plug in a wireless NIC. Yeah, sounds kind of obvious, but we didn't do it before. We've done some privilege changes. So in XP, we run as local system. It's a very privileged account. We still need to run as local system now, because we need access. We need TCP access. We're doing things like manipulating credentials. We're doing conversion between a desktop session ID and a user account. So these are very privileged operations. That said, we have kind of taken the privileges we've got and we've given away all the ones we don't need, so we don't need debug, stuff like that. We actually get rid of those when we start up. And we've moved it to a network restricted instance. There's no need for our service to ever be sending, we're layer 2, we don't need to send layer 3 traffic, we don't need to do sockets calls, so that we actually block that. So there's no valid reason for our service to do that. And finally, good advice, neither one. If you don't need to use wireless, just turn it off. But that's actually a huge generator of support calls to Microsoft, to the OEMs, and to enterprise help desks, because people turn off the wireless switch when they get on an airplane. 5 hours later, when they get off the plane, they're trying to do something, they can't figure out why it works, because they've got the little button turned off. So actually, diagnostics, one of the simple things it does, it'll actually tell you that the reason you're not getting anything happening is you've got to turn that button back on. You're all familiar with rogue APs, so we've made some changes in Vista for this. We don't auto connect to unsecured networks anymore. And also, before association, we do a much tighter capability match between what the network advertises, what the driver's capabilities are, and what we actually ask for in the profile. Plus, if there's 2 access points, one a secure and one an insecure version, they're both broadcasting the same SSID, we'll actually make sure they show completely separate entities in all the UI, report it as separately through the APIs, so there's no chance of those being folded back together. Evil twins, really similar. You try and spoof someone onto ad hoc, lure them onto ad hoc with an infrastructure name. Again, we never auto-connect to ad hoc networks anymore. That's one change. And the second change is we have tighter coupling in terms of networks identified not simply by the name, but a tuple of SSID, what the security settings are, and whether it's infrastructure or on ad hoc mode. So profiles. Profiles are now just blobs of XML. It's probably easier if I just show you one. So this kind of stuff you'd expect to see, information about the SSID, the name, the hex string, whether it's a ESS, meaning it's in infrastructure mode, you'd see if it's ad hoc there, whether it's manual auto-connect, and then security information. This is an open net, obviously this is the BlackHat network, so it's open, there's no encryption, and we're not using 1x. If this was a 1x network, you'd see all the kind of EAP goo sitting below that. So these profiles are that much easier to manage. You can manage them in a text editor, you can export them into different tools, you can move them back and forward through group policy or through command lines. Another difference with profiles, in XP, every single wireless profile, anyone can create one on a machine, and then they're available for anyone to connect and use. Typically, that's really what people want to do, but there are a few corner cases where you actually want to lock down. An example of this would be a shared laptop, where if I took it home one night and set up my home access point, configured my network on it, I wouldn't necessarily want the person who took it home the following night to be able to connect to my home network. So you do have the ability to kind of lock it down, so you can have profiles that are per user, and then anything that's machine-wide needs to be you need admin privileges to modify. Another interesting thing there is we have permit and deny lists. So a permit list is basically a list of SSIDs, and these are the only ones my client can connect to, and a deny list is the opposite. I can connect to anything except the ones in this list. So what can you mess with at this layer? So the extensibility at the service layer was really targeted at IHV developers, guys that are writing drivers but also want to do some user mode code. They have some of their own security method they want to implement. They have something to do, some special power management, that kind of stuff. So they can build an extension DLL. We load it into a host process. It communicates back and forward with the wireless service. They can talk down to the driver, and they can also talk up to the UI. So as we go through the kind of connection process, we go through association and authentication. At each of those stages, we actually call out into the IHV extensions and say, do you want to take part in this? A typical way this might be used is if a vendor wanted to implement their own 802.1x security. When we call out for authentication stage, they can talk down to the driver and say, basically pass on a filter and say, now I want all 1x packets to come to me instead of to the built-in EAP supplicant. When they get those packets, they can either do 1x completely, or if they just want to say do key management, they can actually call back into our 1x engine and drive us. We'll do 1x, they do the key management stuff. Typical things this might get used for is, say, CCX. If they've implemented their own custom service, their own custom security, they're going to have their own set of failure cases. So again, they can kind of plug into that diagnostics and ripple it up to the user. And they can also plug into ePost. and added new EAT methods. We're not recommending any of these, but if your deployment needs them, this is an easy way where you can get new EAT methods onto the machine, and there's a new certification process being built for EAT methods. One thing you notice is that obviously we've added more stuff. There's more connectivity around the base service. There's these new extensions. They're actually running a separate process. Whenever there's a piece of third-party code, whether it's an IHV extension or an EAT method, we're actually going to run that in a separate process, going to control the life cycle of the process. And then if there's any kind of failure in that code, we're going to roll back on an RPC failure or a timeout. So we want extensibility, but we also want to make it as robust as possible. Another thing to point out is that kind of as we're going through this design, you heard some earlier talks about changing the mindset of how we're thinking about these things. So part of the design here was as we're looking at say the IHV extension host, we were going through, well, what can you do that's malicious there? Obviously, how can I insert my own code into there? How can I register my own DLL? Is it possible to overwrite someone else's DLL and inject my code there? What about those RPC endpoints? Can I get to them from another machine? Can I spoof one of those endpoints? Do I need authentication? So all this kind of stuff was done in the threat model, and then we try to make sure that there's a mitigation in the code, and it also reflects back into the test cases, so that a test actually does come back and actually make sure that we did fix it properly.
Question?
Yeah.
Why was TTLS not to be part of the core package?
The reason we have a set of EAT methods that A, we think are secure, and B, that we have IP rights for. The question was why isn't TTLS part of the built-in platform? And the answer is largely because of, I think in that case, of IP rights. So we have made a program available, so there are different vendors that own IP for these kind of EAT methods are actually providing them for Vista. So that they will be available, they just won't be built into the platform.
So I would like to add, you'll see after Vista ships in the next 6 months or so, you'll see a bunch of methods coming online because we are already engaged with them. We have a new framework in Vista, which is not part of this talk, but it's called ePost framework, and it makes it extremely simple to add new EAP methods, and you should probably see something coming up through third parties in the next 6 months or so from Vista.
And again, because we just got an XML format, it's really easy to extend. So if they've done something custom and they need to install their own configuration, they can send it off. We'll move it around through group policy or scripting or wherever, and then pass that information back to the IHV when they need it.
This is the same for the 32/864-bit?
Yes.
Yes.
So the availability of drivers may not be the same, but the model is the same.
The drivers for Vista, all the Vista drivers are required to be 64-bit. So for legacy, you may not be able to have a 64-bit driver, but every driver on Vista will be 64-bit capable. And we do have a bunch of drivers which are inbuilt, and most of the major vendors out there, you'll be able to find drivers for them.
So the next layer in the stack is where we have the wireless applications. So in XP, that's basically the building UI. We still have a standard UI for Vista. Does the management to get the view available network list where you see the list networks you want to connect to, advanced UIs for configuration, managing the preferred list to see which networks to connect to in what order. But also you see that the media center have their own specific UI experience, that they're interested in a kind of 10-foot display, a TV where you can work with remote control, so they just want a different experience. And then we've also added command line support, so most of the things you can do, and in fact, you can do through the UI, you can do command line, and in fact, many things you can do through group policy, you can also do through the command line.